Alright guys, it has been a very long time since I have recorded a video like this for class, so hoping that I can do this in one take and we can um, knock it out of the park and we can all be good to go, okay? We're going to switch a little bit from our atomic structure and the electron configuration stuff that we've been doing past few days, and we're going to go into periodic trends. We talked a little bit on block day about how the periodic table is one big pattern, right? And we have to learn how to read that pattern and look at how things are organized on that periodic table, and it's going to tell us stuff. And that's what we're going to look at here with the periodic trends. There's a few different characteristics like size, something called electronegativity, and ionization energies that we'll talk about. And also bonding, solubility, and reactivity, and all. There's lots of different patterns and trends that we'll look at here based on the periodic table. Okay. With this activity, I would like you to work in groups of 2 or 3. Okay, so I would prefer you to have 1 or 2 partners on this. And more minds together usually give you better results when we're looking at something new. Okay, so it's going to tell you all the way through this worksheet to look at Model 1. Model 1 is on page 2 here, and I want to take a second to look at it just so we kind of know what we're looking at. This is, you can tell, we got hydrogen up here, we have helium over here, lithium. So this is sort of a periodic table. It says down here that the transition elements and the F block elements have been removed. Okay, so we have taken out the D block and the F block, and we are, and we are looking at the S's right here and the P's right here. Okay, so we're looking at the S block and the P block through this little picture here. And there's also some numbers and circles on here, and I want to look at what those mean. This little box right down here tells you what everything is from top to bottom in these boxes here. Okay, so if we look at potassium, the atomic number in potassium is 19. Okay, the element symbol is K. This is what we call the electron shell diagram. Okay, and it's going to give you the how many orbital rings there would be in a Bohr model for that particular element. And it also gives you a good representation, a visual representation here of size. Okay, so K, a potassium atom, is going to be bigger than a calcium atom. You can see that these circles are bigger in size than these circles. Okay, so it gives you a little bit of a visual representation of size. This atomic radius, and note here that this is in picometers. Okay, so that is a unit of distance, a unit of measurement. That's what this number is right here, that 227 for potassium. Okay, so the atomic radius would be the distance from the center to the outside, right? That's what a radius is, and so that's how we measure atomic size, is by the radius. So that's what our that 227 number is right there, is the atomic radius. The first ionization energy is this 404, okay, and I'll talk about ionization energy here in a minute. This is the unit there for ionization energy, okay, and then there's a characteristic called electronegativity, and that's this bottom number here. Okay, so each one of these in this box here from top to bottom corresponds to each one of these from top to bottom in each box. Okay, just so you kind of know what you're looking at when you get to this point here. So it's going to ask you some questions about atomic radius and atomic size. there's going to be reference a couple of times to Coulombic attraction. And we haven't talked about that in class directly, but we have mentioned the main principle of Coulombic attraction. What Coulombic attraction is the attraction of a positively charged particle and a negatively charged particle to attract together. I like to think of Coulombic attraction as the opposites attract law. Okay, so when it tells you, like here, it says using your knowledge of Coulombic attraction. So basically, using your knowledge that opposites attract, and the structure of the atom being, that we have a positively charged nucleus and we have negatively charged electrons in the orbitals that go around. Using your knowledge of those two things, explain the trend that you identified in question number 4. Okay, so that's what Coulombic attraction means when it asks you about that. Then we're going to go down here to page 3, ionization energy. It tells you right here that the ionization energy, we haven't really talked about ions yet, but the ionization energy is the amount of energy needed to remove an electron. Okay, when we remove an electron, then we have more protons than we do electrons, right? In the neutral atom, we have the same number of protons and electrons. In an ion, we have uneven numbers. Okay, so this ionization energy is the amount of energy we need in order to take an electron away from an atom. Okay, so that refers to this, which refers to that particular number. So in this case, because this number is bigger, it's going to take more energy to take away an electron from calcium than potassium. Does that make sense? I hope so. Okay. Let's see. So you got questions about ionization energies. And again, Coulombic attraction, that positive-negative interaction. Electronegativity is the next trend. This is important. If it says read this, you should probably read this. Okay. Question 12 here is asking you to choose the diagram, choose the model that accurately explains this definition. Okay, so what this definition is saying is that electronegativity is basically how strongly an atom's nucleus attracts electrons from other atoms. Okay, so we are looking at the nucleus of an atom attracting electrons from a different atom in a covalent bond. Hopefully you remember from middle school that covalent bonds are shared electrons instead of stolen electrons like ionic bonds. Okay. Electronegativity, if we go back to this page, electronegativity refers to the bottom number. So this 0.8 here and this 1.0 here for calcium. So according to these numbers, calcium has a stronger attraction for electrons from other atoms. Okay, that's what, the higher the number, the stronger the attraction of the electrons from another atom. Okay, let's see here, more Coulombic attraction. With this, you have 3 different trends that we've talked about. We've talked about atomic radius, we talked about ionization energy, and we talked about electronegativity. Okay, you can abbreviate each one: atomic radius, ionization energy, and electronegativity. Okay, what you're going to do, these 2 trends on the periodic table can be used to describe each one of these. You just need to pick which periodic table represents each one. So if you think that the atomic radius, which is your size. If you think that the size of atoms is low down here and high up here, then you would say this is my atomic radius. If you think ionization energy also follows the same trend, you'd say you'd do this, and then electronegativity if you think that that is the trend over here. I will tell you this, what I've got here is not the right answer. Don't just copy my video. Okay? That's not the right answer, but that's how you would do it and how you would handle it. Okay? Let's see. There are some extension questions down here. If you need to, use some outside resources. I'm okay with you using the internet for these if you need a little bit of outside information. This is probably the one that I want you to answer on your own as best as you can. Okay, number 16 there. Let's see. I think that's all I want to discuss with you guys. I hope that this video helps you to get kick-started and get going on this video. If you need to, watch it again. Okay, watch it with your group members, with your partners. That's okay. If you want to share AirPods or play the volume on low and you're not disturbing your other classmates, make sure that you are good and well behaved and on task for your substitute. And I will be back on Tuesday. Don't know yet the plan for Monday and Monday's class, but we will figure it out as we go along. Okay? I'll see you guys later. Have a good weekend. Go Chiefs. Heck yeah.